We want to turn our attention now to the graphical representation of continuous data. And what we're going to do is to start with the basic plots that R can create. These plots, as you will see, are useful for data exploration. So typically you would use these plots early on in a research project, but they're not typically going to be high enough quality to be published in a journal. But let's load one of our familiar built-in data sets that we used with the last exercise. Let's look at the iris data set again. So that's built into R, so we don't have to look externally for it. So, and there we have iris. So let's stir iris like we usually do, refresh our memories. So we have 4 different numerical variables, and then we have a factor variable, which is, in this case, species. So let's just take a look at some of the quick and easy graphics that R can create without having to use one of the external packages like we'll be doing in just a little while. Let's just say that we want to take a look at the histogram of petal width. And R is pretty smart, so we told it what data set to use and petal width, and we said just make a histogram for us, and there it is. So again, bare bones, but it's useful, and what we can see is an interesting distribution. And of course, this distribution is a bit confusing because we've actually lumped 3 different species together here, and they turn out to differ in size. But at any rate, that's how we'll see how we can split those out later on by species. But that's a quick way to make a histogram in R without having to install a package. We can also do the same thing for making scatter plots. So that's an easy command as well. We're just going to say plot, and we'll say iris. We'll do sepal width and iris sepal length, and we'll run that. And we get a graph there with very big open data points. But what we can do is to visually look at that and think, well, maybe there's a slight positive slope to that line. It's not quite clear. But in R, so these base plots in R can be useful when you're just taking a look at your data. But if you really want to prepare a graphic that would be worthy of appearing in a scientific journal or in the New York Times or on Facebook, then we're going to need to go to more sophisticated graphics packages. And what I want to do is to quickly go into PowerPoint here, and I want to talk a little bit about an innovation in graphics that's only taken place in the last 10 years or so. And it's a whole concept that is referred to as the grammar of graphics. And the idea is that languages have grammars. So if we want to convey meaning, impart meaning, then we use nouns and we use verbs and we use adjectives to communicate with each other. And in 1999, a man named Leland Wilkinson came up with the idea that graphics also could have a grammar. And ultimately it was published, he published his definitive book in 2005, which was called The Grammar of Graphics. And the idea was that just as we have nouns and verbs and adjectives in language, we also have the similar sorts of components that can be used to make up graphics. And what Wilkinson did was to come up with a number of these components, and we start with data. So we have a data set of some sort, either continuous data or discrete categorical data, and we map the data to things that we can see, and he called these aesthetics. So aesthetics are the points or the lines that represent the data. And that representation is done on some sort of geometric object. It could be a 2-dimensional plane, for instance. It could be a histogram, it could be a line through points, it could be a scatter plot. So those are called geometric objects, or as you will see, we just call them geoms now. We could also transform the data if we wanted to. So maybe we want to do a log transformation on the data. And finally, we may want to break the data down according to, say, species, if we have multiple species, or time, whatever. The mechanism is that we could break our data into different parts. And so we call that conditional specification, or sometimes we call it faceting. And facet is in fact going to be a term that we use when we prepare graphs like this. So along came a graduate student soon here after the Grammar of Graphics was produced, and his name is Handley Wickham. And Wickham is a superstar in R. So he developed a way of using R to implement the grammar of graphics. And so what we're going to be doing is using a package that Wickham created. It's called Ggplot. Gg, of course, stands for Grammar of Graphics. So let's go back into R. And what you're going to want to do next is to install that particular package. So install packages, and this is called Ggplot, and this is the second version, so we're going to call it install packages.ggplot2. And it says that I already have it loaded in my machine, but you shouldn't get this command, so we won't worry about that. So I'm just going to cancel out of that because I already have Ggplot2 loaded in my copy of R. So what I'm going to do is to make sure that it's running. So, and that's good. So if I went into my packages, I could find Ggplot2 there, and it's ready to go for me. So we have Ggplot set to go. Now what we're going to do is to start fairly simple. So what I want to do is have you take a look at the Crabs data set that we were looking at the other day. But what I've done is to modify the data set a little bit. So even though it's built into the mass package as we downloaded the other day, what I've done is to alter it slightly just to make it a little more straightforward in terms of the labels. So what you need to do is to download Crabs off the Moodle page. So you should be able to find it there. It's a CSV file. So what we're going to do is to load it into our respective copies of R. So and mine I think is in the downloads. So there it is. So I have this I have Crabs in my environment here, so you can see that it's loaded up and 200 observations of 8 different variables. So let's take a look at the first few lines just to see what we've got. And one thing that I did was to go through and I changed the morph from just B and O to blue and orange, so it's a little clearer. And also I changed sex from M and F to male and female. But that's basically the only thing that I did. But what we're going to see when we go through and make graphs is that once you get a data set into R, it's not easy to change it. And actually that's the way it should be, because you don't want to be analyzing a data set in R and inadvertently make a mistype and change your data set. So it's not easy to change the data once you have it loaded into R. So the best way to get your data labeled properly is to do it before you even load it into R. So when you're still in Excel, to get your labels the way that you want them. So anyway, we have Crabs loaded up now, and we have Ggplot all loaded up. And what we're going to do now is just to start our plot, and I could call this my plot if I wanted to, right? Or whatever I want to. I could give it any sort of object name that I want, and could continue that. on out. But what I'm going to do, and you might want to do that, and in fact, I will do it at the very end. But what I'm going to do is just to add layer after layer onto our developing plot. So what I'm going to do is just to start out with the basics of a Ggplot data set. So what I do is I just type Ggplot. I don't need the 2 there. And I tell Ggplot what my data set's going to be, and it's going to be crabs. And then I have to put in the AES. So this is going to tell me the particular variable or variables that I'm interested in, and the AES obviously stands for aesthetic. So it's the way that the data are going to be mapped onto my developing image here, and I'm just going to do the frontal length. So the FL is frontal length, and so I have started. So I've told Ggplot that I want you to map frontal length of these 200 crabs, and what can you do for me? So I'm going to run that, and nothing happens. As a matter of fact, we can see down here that there's an error because there are no layers in the plot. So I don't want to take this metaphor too far, but essentially what I've been doing by saying, what I've done by saying Ggplot crabs AES FL is I have specified a noun. I've specified the things that I want Ggplot to work on, but I haven't given it a verb. I haven't told it how I want that particular information plotted. So what I'm going to do is to specify a geometric object. So I just do add, and I'm going to put, again, they're called geomes, and there are a number of different kinds of genomes, but I'm going to be interested in a histogram. So I'm going to do that right now. And then I'm just going to put open parenthesis, close parenthesis. And what Ggplot will do is to say, okay, I'm just going to go back to the last parentheses, and I'm going to accept that as the same information. So really, if I put crabs AES FL here, that would be fine, but I don't have to do that because Ggplot is going to go with what I have here. So now I've specified essentially a noun and a verb, so I should be able to get something. And I'm going to run that, and I get a very nice little histogram there. And you can see that I've got the FL comes from my data set, and I just got the count that you can see there. So, and the histogram itself is in black. So let's see if we can change some additional portions of this developing figure that we have. And let's say that I want to change the Xlabel. I want to make it a little more descriptive than just FL. So what I'm going to do is just to, as we were doing earlier, we're just going to use Xlab, but in this case I call it the frontal lobe size. Oops, make that capitals. And just so the reader will know what it's going to be, I'm going to put it in millimeters. So let's run that, and now I've got a new X label. I could also do a new Y label, and that's going to be a similar sort of procedure. So I'm just going to call it frequency, and I'll run that. Oops, it didn't like that because I put in wrong. That should be a plus sign. So I've got that there. I can also give it a title, but when you're in Ggplot, you can't just say title. What I've done here is to add a plus, and then I hit return just to get me down to the next line so we can see everything here. And again, in Ggplot, we can't just say title, we just need to say GG title, and I'll just put frontal lobe variation for my particular title. One item is that whenever you are hitting a return to go to the next line so you can see everything in your source panel, make sure you don't start a line with the plus, otherwise you end up getting an error. So lab frequency plus, and then I just hit return, and I added the rest there.